Welcome to Breadboarding. I was just going to interrupt the current 386 Breadboard PC series of videos to cover an update to the Programmable Logic Devices. The reason for this is that WinCUPL II has now been officially released. It's now at version 1.1. The beta of this was released in August 2025 and I've been using that in most of my videos since around September. Not really had too many problems. I thought I'd just show you an update to show the improvements and where there are still one or two minor issues for improvement. So this is video 10 in the Programmable Logic Devices series, and this covers the WinCUPL II release. So in the videos earlier in the series I had a number of slides to do with how to use WinCUPL and about the documentation, and I've resurrected some of those slides and I'm just going to go through them to call out where the differences are. So if you're actually looking at any of the earlier series, and there will be a link in the top right hand corner here for the playlist to go through the whole series, and there will be links in the description below the video as well. So in order to install WinCUPL II from Microchip, we just actually click on the same link that I provided in the previous series, and when we go into the WinCUPL, we'll now find that the original WinCUPL 5, which was the very old Windows XP supporting version, this has now been replaced really by the WinCUPL 2, and this was at 1.0 since around August, and I think this must have been released within the last month or so. So to install it, just download it, unzip it and run the installer, and you'll end up with a WinCUPL folder. And again, it does recommend you install it in the WinCUPL folder off your C root directory and don't include any spaces in it. Now when we actually have a look at what's in here, it's very similar to the previous version, but you can see that a lot of the command line versions are all from 2004, and this is basically just a shell that calls these various CUPL and fitter executables. So it doesn't look like there's been too much update to any of the underlying components, but the whole GUI layer has been refreshed. And there are now examples, all the examples are in their own folder. That does make things a bit easier to see all of the generated files and things, but there are one or two problems to do with the samples, which I'll cover in a few minutes. So let's have a look at it. So now when you run up WinCUPL, you need to actually create a project file first, and that's the first issue really, is that if we were trying to look at some of the samples, you actually have to create a project file first before you can even look at a sample. So if we look at the I/O decoder, for example, what we actually need to do first of all is to have a look at the example designs and see that the I/O decoder is actually an ATF22V10 28 pin PLCC, and the reason why we need that is that when we create the project file we have to specify that, and there's a good chance if you try and compile it, it may not necessarily work. So we're actually going to have a ATF22V10C, it's the 28 pin PLCC, and we won't choose any special options. So we now need to provide a file name for it as well, and in general I normally just copy the PLD name and get rid of the PLD. So it detects there's already a design file in there, and there's also a simulation as well, and then it shows us now the two files that we have in here. Now I'd recommend now at this point in time we save it, and the reason is I'll explain in a few minutes. So if we now have a look over to the compiler options, there are a few things we might need to enable. So in particular, if we want the equations and the fuse plot in the doc file, for example, it's produced in the GED file. There is the quick minimization. You might want to enable some optimization. Certainly if a design doesn't fit, then you may need to apply some of those optimizations. But in general, all we need to do is to compile it. You can see it runs the command line versions in the background there, and now we can actually see all the output files. So if we look at the doc file, you can see that this is the documentation file with the fuse map, and this particular version doesn't produce a very good chip layout for the PLCC version. If we use the DIP version of this, then this would actually produce a better output. And it does also include the design simulation. Because this one has the simulation file here, we can click Simulate. Now this doesn't have the same GUI of the previous WinSim version. And if we look at the simulation output file, then this will actually show us all the various rules that have been executed. And if there were any problems with any of these rules, then it would actually highlight in here. So the lack of the WinSim graphical output is not really a big issue. We can still determine whether or not the tests have executed or not. So what are the problems with this? Well, the biggest issue really is that if we now save the project file here, and if I was to go into this folder and to perhaps delete some of the files, so let's just delete some of the files down the bottom here. So we've deleted most of the output files here. So we've still got the WCP, which is the project file, the SI file, which is the simulation file, and the PLD file. Now, if you remember, I saved this when I actually had generated all these files. If we now just exit and run up WinCUPL again, if we now try and open our project here, we'll find that ABS file does not exist. And in fact, any of those files didn't exist, then in fact it won't allow us to open the project. Now I would say that's quite a major issue really, and in fact the only real way how you can work around it is you've got to create a new project file. So in fact you need to create a new project file. This time I'll create it with a 24-pin DIP, create project. We can actually select that and overwrite it. It's brought it in. We now do compile. It's probably failed because we don't have enough pins because of the pin layout and stuff in here. But you can see that that's one of the problems with a new WinCUPL, in that if you do actually delete any of the files, or you perhaps move your project file to another machine where you haven't already got all of the output files, then it won't actually open the project file. This doesn't really seem to be the way how you might expect it to work. By all means warn that a file doesn't exist, but you shouldn't prevent a project from opening just because some of the internal working files don't exist. So although WinCUPL 2 doesn't crash like it used to, there are one or two issues there which I'll summarise towards the end. And now what we do is use the design flow option and compile, although you might need to go into the options page to set some of the output options if you want some of the additional output in the doc file, for example. Now as far as all the documentation, that's really where things have really improved a lot. So I went through a number of slides going through where all the information was buried in the original WinCUPL, and in fact that has greatly improved. So in fact, if you go to the contents first, then you'll get a nice overview, general background information, some sort of diagrams and things about the actual design environment. And the device options and CUPL extensions, this is really the bit that was quite tricky to get. You had to look in combinations of the release notes and the device PDF. Now this actually includes all of the extensions by the different devices, and that's a lot better than it was previously. We've got a list of the example designs, which is good apart from the missing project files. And I suspect one of the reasons why there may not be project files there, that if you actually save the project file after you've generated all the output, then no one will be able to actually use that project file to open the project if it didn't have the compiled outputs. And then there's some error messages, so if you do get errors, then there's the explanations of what those are. So this has been a great improvement. And then in WinCUPL itself, there's also a tutorial. So the quick start tutorial is very similar to what you had previously. We'll take you through how to create the project with the device, although it does then say at the end, save the project once you've created all these intermediate files. So if you ever copied the project file onto another computer somewhere, you would not be able to use that project file. So that's something that probably does need to be addressed in a future update. Then there's a user's guide. Some of these have got preliminary on them, so hopefully these will be finalised. I suspect some of the diagrams in here may look like they may have come from earlier versions, and they might be looking at perhaps redoing some of these because one or two of the diagrams in other documents are not perfect. And the CUPL reference guide, again, this is a big improvement in that previously this information was only in a Windows help file, which you couldn't actually use in later versions of Windows. I did show in the earlier series I'd actually used a help to Word generator to actually create a Word version and a PDF version of this, but this is a great improvement. But again, some of the diagrams in here are a bit rough around the edges. They have come from documents from about 20 or 30 years ago, which have sort of jaggedy bits around some of these diagrams. You can see they're a bit pixelated here, but perhaps what they're hoping to do is to tidy up some of these perhaps in later versions. The fitter manual is a little bit shorter than the previous version. There is a tutorial, although don't save the project at the very end there, or else you won't be able to use it on any other machine. And the example list PDF has 44 samples. 10 of them are relevant to the ATF16V8 and the ATF22V10, so there's slightly more examples for these simpler chips. Most of the examples are for the ATF750C, 1500 and 2500, and just be aware that if you're buying a programmer, then to use the 750C and the 2500, then you need a high-end programmer. Now, a number of people have asked about what programmers I use. Now, the original series, I used an earlier generation programmer, the 86 version 2, I think it was. But that's now been replaced by the T48 programmer. So this is probably sufficient for most people's needs, unless you want to use some of the more advanced PLDs like the 750 and the 2500, which I haven't been able to get the 2500 to work even with the more expensive programmer. This is probably going to be an adequate replacement. Now, you can get it through Amazon. You can also buy them on eBay, quite a bit cheaper. The T56 that I have is no longer made, but the T76 actually comes with quite a lot of these adapters. So these adapters allow you to program a variety of PLCC chips and things. It is a lot more expensive. I believe you can get it a bit cheaper than that off eBay. But really, if you've not done any of this before, I'd start with the T48 for about £50. And then if you really find that you want to use some of these more advanced chips, then look at finding a cheaper place to get your T76 from. There are still some of the documents that I referenced in the previous video. So there's a very old document here from Logical Devices, who are the original manufacturers of CUPL. So that has some different information in from some of the others. There's also this document here again, which has certain CUPL references. There are still certain guides and things up on the microchip atmel pages, and there's obviously the documents under the chip definitions, and now the WinCUPL II help files are actually got most of this documentation as well. But it's always worthwhile having a look at some of the other documents, because sometimes there's things they cover in there that may not be covered in the same level of detail in later versions. So in summary then, WinCUPL II is a big improvement, but there are a few minor issues. I've been using the beta since September 2025, and it has been reliable. I've not really had any problems with the tool in any of the outputs. As far as the improvements that could be made to it, so if Microchip are listening to this, thanks for providing the updated version, but there are a few little rough edges. So the fact that no project files are provided with example files is a bit of a blocker for somebody trying to sort of find their way around using a tool, because unless you chose exactly the right device type, then you're probably not going to be able to successfully compile them. When saving a project file with all the generated output files, this will then prevent the project from opening whenever these files are missing. So it means that you couldn't actually share a project file with someone else if you've ever saved it with these output files. So the workaround really is you have to recreate the project file, which does seem a little bit poorly thought out. The fitter manual is marked as preliminary and is a bit shorter than the one provided with version 1. And there are some examples in the appendices. I'm not sure how relevant those are. There's no WinSim simulator graphical view or similar output. That's not really a big problem, in that if the tests fail, then you'll get a notification in the simulator, and then you can then check the output file to see where the problems were. Again, the tutorial suggests after successfully compiling and simulating the design that you save the project. So this will save the project with all of the additional generated output files, and that will stop you ever using that project on a computer where you perhaps haven't got any of those outputs already. So in summary, it's a big improvement. All of the links and things I've included in the previous videos should now work to take you to the latest WinCUPL II. So for all future videos, I'll be using this 1.1 production release. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe. And if you found the content interesting, please hit like. It just helps to make the videos available to more people.